Good morning, everyone.
Good morning.
Good morning.
All right. Uh, how are you guys? How are you finding the material? Any comment? I hope you are hearing me, getting me clearly.
Yes, it's good.
All right, fine. Today we will start a new chapter. So we have serpent, we have honed our tools, we have looked at linear equations, and we have also looked at chapter 2, how we solve a system of linear equations. So today we will look at some of the application in microeconomics, which is supply and demand analysis, or if you want to say demand and supply analysis, the same thing. So we will be looking at that. Supply and demand analysis. How do we use linear equation to solve some of the problems we find in demand and supply analysis? So for us to have a good understanding of chapter 3, that's why I said that the prerequisite for this course is like we assume that you have taken introduction to economics or principles of economics, because some of the laws, the concept that you will see, you will realize that they are coming from economics. So your knowledge of economics will serve you here well. So first, in supply and demand analysis, we will look at a functional notation, a very brief introduction of to what a function is, functional notation. We will look at this. Uh, we will look at functional notation such as y equals to f of x. That's where we will start with on the demand and supply analysis on the chapter 3. We will also look at what do we mean by exogenous variable. You will see exogenous and endogenous variables in economic models. We should be taking note as well. We cannot depend on these recordings 100%. Sometimes they can go bad, south. So that is endogenous and exogenous variable within economic models. How do we identify them? What are they? So these are the things we will learn. These are the learning objectives. We will also try to, look at linear demand curve. We will look at linear demand curve. We should be able to identify them and sketch them. We will do that here and how we sketched. So we will also the same thing for supply, linear supply curve. So the same thing, we should be able to identify them and as well as sketch. So the fifth, so we will look at equilibrium. We will look at equilibrium in single market, in a single market. In a single market, that is the equilibrium for one good. So then the sixth one, we will also look at equilibrium. So equilibrium in a two market. We can go up to 4, 5, but we will limit ourselves to here, two market. So these are the learning objectives under this that we want to cover. So as you have to take note as well, as I said, you can't depend on the recordings always. Let's be taking notes as well and make your own note as well. The material I share with you, we have all these there as well. So today, if time permit us, this is what I want to look at. From 1 to 3, then the next class we look at 4, 5, 6. So today, this is a goal. We want to cover this if time permit us. Then the next class we can look at this. So let's go on. So the first one, we looked at the functional notation. So first, we have been seeing this like a linear equation whereby we have y equals to 2x plus 3. So when we graph this, we'll have something like this. So y will be here and x will be here. So obviously this will be our y-intercept, which obviously will be here, that is 3. So when we looked at our x-intercept, we will have something like this. So this will be negative, so it will be around here. So we might have something like this. So we have y here and x here. So this is a linear equation. So, but we can represent this linear equation in terms of function. So we will not go deeply into functions. We will have an opportunity to do that in as time goes on, but just a brief introduction here. So when we want to represent this as a function, what we can do, we can just say y equals to f of x. So this f of x, we read it as f of x. That's how we read it. So this f of x, which is this, it's nothing. We can represent this linear function as this, 2x plus 3. So this f of x is nothing but representing the y value there. So if we are drawing the graph, instead of y, we can just set f of x. And we have the y. So nothing changed. Over time, you will see why we are using the function. So in another word, function is just a rule. Like when you are looking at this, we can call it function what? F. Because the letter there is f. So the name of this function is what? Is function f. So when we talk about a function, it's nothing but a is a rule that assigns to each incoming number a unique outgoing number. So let's look at this in details. So we have this, so we can represent this as a function, and it will look like this: f of x equals to 2x, 2x plus 3. So this is our function, and it's a linear function. So let's look at this in detail in the next slide. The class rep, please, you can take the class attendance. Okay, so let's have this. We have a linear function like this, 2x plus 3, and we can change it to a function by removing y and putting f of x there, which equals to 2x plus 3. So if you look at a function, like, what is a function? It's just a rule. Function is a rule that assigns. We will demonstrate this definition with some example. You will understand what we are trying to define. It's a rule that assigns to each incoming number. Don't worry, I will explain the meaning of this definition using some numbers. So the incoming numbers here is what? Is the x. Incoming numbers to a unique outgoing number, and the outgoing number there is nothing but what? The y. So let's look at this definition and try to understand it. This is the definition of a function. It's a rule that assigns to each incoming number. So we have this function here, which is f of x, 2x plus 3. So the x there is the incoming number. And this f of x, as we stated, is nothing but y. So y is the what? The outgoing number. So the function there, which is this f, what it does is assign the value of x that will lead to the value of y. For example, we can represent function as a kind of a machine. So what we will see here, the output. So this is the output. And the output there is nothing but the y, which we said is the same as f of x. So then the incoming number is nothing but the x. This is the x, and this is the f of x. So this box here, this is the function. So functions serve as kind of a machine whereby you put the input. X there is the input, and f of x or y is the output. So what does the function do? So the function there is what? Is the 2x plus 3. So in another word, you double and add 3. This function is just telling you double. So the f of x there is telling you double x, and then add 3 to it. So you can see function as like this. You have an input, sometimes we call it incoming number. Then we have a machine. When you put the input there, for example, if we said x is 3, then the machine will some kind of what, this 3 will be loaded into this machine, which is 2x plus 3. Then you will have an output of what? 13. So that's why they said it's just a rule or it's just a machine. We can see this as a black box whereby you put an input there, then it will cook it, then you have the output. So it's just a rule that assigns the value of incoming number and a unique value of outgoing number. So whenever, if you see y equals to 2x plus 3, or you see f of x plus 2x, they are the same thing. So about functions, we will talk about them more when we start our differentiation. But don't be confused. If you see f of x instead of y, we are talking about the same thing for now. So that brings us to functional notation. So this is our functional notation, and we read it as f of x. Sometimes instead of f, you will see other letters like g. It can be g of x. It can be double of x. So what they are doing, they are just representing is, they are replacing y value in our two-dimensional figure, plane geometry. So don't be confused once you see f of x instead of y. We are talking about the same thing. If you have a question, you can ask before we go on to the next topic. So, for example, we can have a function like this. Let's say if g of x is equal to 3 over 5 plus 2q, we have this. And the question asks you, the task or the question says, evaluate or it asks you to find, let's say a g of 2. So they are asking you to find this. So what this means, it is telling you in this function, in function g, this function, the name is g, you use the letter. In this function, wherever you see x, replace it with 2. So what we will do to solve this, it will be g of x, g of 2, we are removing the x there. We are saying that x is equals to 2, is equals to 3 over 5 plus 2 times q. And we are saying, sorry, this should be q, not x. Let's be consistent. So this is q and this is q. So they are saying wherever you see q in this function, replace it with what? 2. So exactly is what we are doing here. We have 3 over 5 plus 2 times q. And in this case, we are saying this means q equals to 2. That's another interpretation. So we have 2 times 2. So we will have what? 3 over 5 plus 4. So here we have 3 over 9. If we further break it down, we'll have 1 over 3. 3 here once, into here 3 times. So we have 1 over 3. You can stop here if you prefer the fraction. So to evaluate this, what it means is to replace q with 2 in g function. So basically, one can also write this function as, instead of g of x, we can write y equals to 3 over 5 plus 2q. So basically, this should not confuse you. It's just taking the place of y. So after that brief introduction to, very, very short and brief introduction to functions, let's look at some of the terminologies that you will be seeing. For example, let's have a linear function like this, y equals to 2x plus 3. What we also want to know here is that we want to know what do we mean by dependent variable and independent variable within a function or within a linear equation. So here, x is an independent variable. We need to know this. So terminologies matters. Why is a dependent variable? And the reason why is a dependent variable, the value of y, to determine the value of y, we have to know the value of x. So within equation, this is also, we will be talking about, you will be hearing independent and dependent variable. So obviously 3 is, we have talked about this, is a constant, while this one is a coefficient. We need to know this terminology so that when I say coefficient, you will exactly know what I'm talking about. So we have these things. So after brief introduction to functions here, then we are done with this. We will come back to this. So let's look at a linear demand curve. We will come back to exogenous. Let's look at linear demand curve. So we have, let's look at linear demand curve. Obviously, as I said, the prerequisite for this course is that you should have taken an introduction to economics, because this course is mathematical economics. It's not economics, but I will try my best to explain some economic concepts. So let's assume first, the first assumption that we will have here, the first assumption we will have here is that we have to assume the relationship, because one thing first, we need to know the linear demand curve. It just shows the relationship between what? Price and quantity demanded of a good. So first of all, linear demand curve, it shows where we should even start with. You know, so linear demand curve what shows relationship. So between two variables, that is the market price or the price of the good, the price of the good. So normally we represent this as P, as P variable, and what? The quantity demanded of a good. The relationship between the price of the good and the quantity demanded of a good, and we represent it with variable Q. So relationship, so linear demand curve just show relationship between P and Q. That is the price of the good and the quantity demanded. So we will have P and Q, but we have to make an assumption. This relationship, is it linear or non-linear? So for this case, we will look at the linear case for this part. But in our, over time, we will also look at non-linear relationship. So for here, this is what we'll assume is the relationship. That's why we have this here, linear. The relationship could be linear or non-linear. So we assume that the relationship for now is linear. The relationship between price and quantity is linear. And when we have such a relationship, then we can represent it in a function like this. So we can represent it as quantity is a function. It can be represented as P. Or we can also represent it as price is a function of quantity. So both these ways are correct. So a specific example could be what? We can say quantity is equals to, let's say, minus 2P plus 10. So a typical example here could be this. P equals to minus 4Q equals to 20. So this representation, they are nothing but a demand curve in form of equation. These are demand curves. So these are what? Demand curve or demand functions, to be more specific. In fact, demand functions. So we have two ways of representing demand function. This is the first one, and this is the second one.
Sorry,
So,
Mr. Ture.
yes.
What does the G stand for anything?
G is just a function. So the first one, this is function F, and this is function G. Okay. They are all functions. So we are distinguishing them. So F is a function. This is first one is function F. This is function G. In function F, Q is a function of P. In function G, P is a function of Q. So in first one, the function name is F, and the second one, the function name is G. So in function F, the Q is the subject of the formula. In another word, Q is a function of P. So in function G, P is a function of G. So both these ways are allowed when it's come to representing demand function. But what we will do here, we will depend more on the second one. But whichever way you take, it's correct. So it's whereby P will be a function of Q. So this is what we will be using most here. But whether you use first or second one, you will arrive at the same answer. It's just a matter of changing the subject of the formula. So this is a typical demand function. So this demand function, we can represent it in a graph. So when we represent it in a graph, we will have a linear straight line. So here it will be what? Price intercept. We know how to calculate price. We know this is the same, before it's just like y-intercept, and Q is the same as x-intercept. But for this case, these are applications, we have price and quantity, not y and x. So we need to know how to calculate the price intercept. This is price intercept. And this is quantity intercept, or in short, we can just call it now, from now on, P intercept. So this is what quantity intercept. So we have this. So we are looking at a demand function, which is this. It could be like this, or it could be like this. But as I said, we will be going with the second one. So if you have, this is telling you price is a function of quantity. Price is a function of quantity. So a specific example could look like this. So we need to know how to identify and sketch a linear demand function. So let's look at here. First, we started with here a linear demand curve. We said that demand curve, it shows relationship between price and quantity. And the relationship between price and quantity, it could be linear or non-linear. But for now, we are focusing on the linear one. So when talking about linear, we are just saying that the demand curve will be a straight line. So we said that for demand function, we have two ways of representing them. We can say that Q is a function of P, or P is a function of Q. And for this class, this is the representation we will be using. So making more clarification like this, like demand function, we can have Q as a function of P, or we can have demand function as what? P as a function of Q. So I make emphasis on that. This is what we will be using here. So the demand function that you will see price first equals to, maybe you can have minus 2Q plus 20. This is the kind of demand function you will be seeing. So, but this is a specific case. Can we generalize this? Yes, we can generalize it. So a demand function looks like this. It could be like P equals to, we can have P equals to A times the quantity, A times the quantity plus B. So this is a general representation. So our demand function will look like this. So we can have, for example, in this case, the P, we can have here, the A here is the minus 2, and B here is the 20. Then we have Q. So we can have a demand curve that looks like this. P equals to minus half times Q plus 15. So the minus half there is nothing but the A, like this. The 15 there is nothing but the B. So one thing we have to understand also that, how do we remember, we said the relationship between price and quantity is what? Is linear. But we want to know whether the relationship also is negative or positive. Is the relationship positive? Yes? Or negative? I'm not getting you very well.
Why is it that you have minus half or minus 2?
I'm not getting you very well. Your talking is breaking. It keeps breaking. But can you repeat the question again, please?
I said, why is it that why is it that it is minus half instead of minus 2?
No, this one, the question, that one will be given to you. This equation may be estimated by econometrician. You understand? So it can keep changing depending on the slope. You understand? Whether the relationship is strong or not. You understand? A particular commodity and price, the relationship might be strong, might not be strong. So the negative one, it could be -1, -2, -5, -6. It could be. So the higher the number, the stronger the relationship between price and quantity for that goods. These are some of the things you should have seen them in economics already. So if the negative there, because what this negative is telling you, that is the A, it's showing you if quantity increased by 1 unit or quantity changed by 1 unit, how much price will change. So if the number there is bigger, then it's telling you that the relationship between price and quantity is very strong. But if the number is smaller, the relationship between the price and quantity is not that strong. So this A or -2, this A is nothing but the slope of the, but we will get to that point, is nothing but the slope of the linear demand curve. So the higher the absolute value of this, for example, this -2 here, we have -2 here, we have half here, minus half, which is the same as -0.5. So this one, this relationship, this demand curve is telling you that the relationship here, it's stronger between price and quantity than here. So it can keep changing, it's not constant. It's not going to be like -2, -2. What the interpretation you can make there, the higher the number here, forget the minus, the higher the number here, the stronger the relationship between price and the quantity. So the lower the number, the absolute number there, the weaker the relationship between price and quantity. That's the interpretation. So A is just nothing but the slope of the linear demand curve. And what do we mean by slope? Is the amount. So if quantity change by 1 unit, the price will change by a unit. For example, if quantity increase by 1 unit, the price will reduce by 2 units. That's the meaning of these two. So for here, if the quantity, let's say quantity increase by 1 unit, what will happen to price? Price will fall by half. So this is telling you that this one is increasing, this one is going down. So it's telling you that the relationship there is even negative. So that's why we have the negative sign here. So A will always be less than 0. So if A is less than 0, look at your number line. We are talking about it has to be a negative number. I hope this answered your question.
Sure.
If you have questions, bring it more, because this will lay the foundation of what we will be doing from now on. If you have questions, ask. These points, this demand curve needs to be cleared. It needs to be understood very well for people to understand what is coming on. But normally this relationship should, you should have seen in your principles of economics. This is a mathematics course. I should just have come and try to do the mathematics. But from my experience, it's not the case. So that's why I'm taking my time to explain this economic concept. So we have, if you have questions, please bring them, ask. Let's make clarification before we go further. If you have more problems.
Mr. Toure,
yes?
Yeah, for this relationship, like A and B, from my understanding, it means like A will be always negative.
Yes, always.
Like A will be positive. Oh?
Yes.
Okay.
A will always be negative because this is a demand curve. And if from your introductory economics classes, the relationship between price and quantity is always negative. I don't want to go back to draw demand schedule and something like that. But here is the thing. What we need to know here is this, NUP. So this is how our demand curve will look like in this class. So we will have, this is a general case. This is, we will take more time to explain this because it's the foundation. So then we have the quantity, then plus B. So this is a general case. So